We will do one exercise. Let's assume that you want to multiply a number by 2 using shift instructions. Mean to say, I'm not going to use multiplication, addition or whatever. I'm going to use shift instructions to multiply a number by 2. Okay, so this is the idea. Okay, let's look into a few examples. Let's assume you have a number 5. You multiply by 2, you get 10. Let's assume you have a number, let's say 10. When you multiply by 2, you get 20. Okay, so whatever is it. So let's see the number in binary. So when you have 5, it is 101. And when you multiply by 2, you get a 10. What is the binary equivalent? 1010. So this is the binary equivalent of your source and then the result. I mean input and the result. Okay. Same goes with this 10. The binary equivalent is 1010. When you multiply, you get a binary equivalent that will be 10100. Okay. So this is the binary. Whatever number you take, any number, what is the input? Binary equivalent of the input and what is the binary equivalent of the output? Just look at them. You will see one new thing. What is the new thing you see is, can you see here, the input contains certain digits like 1010 or 101, but the output has one. When you see the output, you see some like kind of similarities for the input and for the output. What is the similarity is, you have 101, the output also has 101 added with 10. The last digit added is 0. So let's look into the next example. Your input is 1010. The output is also 1010 added with 10. Okay, where is the one additional 0 is added? On the least significant bit on your right. Okay, least significant bit, LSB. So I want an LSB onto the least significant bit. So what can I do? How can I solve? So the solution is, let's read or assign a value to a source register, let's say 5. Then you shift simply to the left side, T0, T1, 1. If you shift by 1 bit, that is the result for the question. Okay, you can try it and you can find the output. So this is the solution for the question. Here I assign a value to T1. If you want, you can read a value and then that value you can multiply. So when you shift by 1 to the left, this is the equivalent, multiply by 2. Okay. The same goes for another exercise. If you want to multiply by a number by 4. So I'm going to use same using shift instructions. Okay, so what is the question here is multiply by 4. So let's assume you have maybe 3 multiply by 4, you get 12. Later we will see the binary. So let's say you have a 5. When you multiply by 4, you get 20. So let's look into the binary equivalent. 3 means 1, 1. This is the binary equivalent. The answer what you get is 1100. This is 12. Binary equivalent of 12. What is binary equivalent of 5? 101. This is the binary equivalent of 5. What is the binary equivalent of 20? 10100. So what is the similarity between the input and the output? Let's say first exercise, input is 11, output is also 11 added with 2 zeros. Let's say the second exercise, input is 101, output is 101 added with 2 additional zeros in the least significant position. So the solution here is you read or assign a value. So I'm assigning a value. T1 is, for example, 5. And then shift left logical. The destination will be in T0. T1, shift by 2 to the left side. You will get the output. Fine. So this is another exercise. In the last video, we saw logical operations. We saw certain logical operations, for example, and, or, and then nor. These are the operations we saw. Now we will see or solve one question based on this logical operation. Let's assume you want to check whether a number is odd or even. I'm not going to use the branch or divide by 2, take the remainder and check it using the branch. Is it equal to 0? Then it is even. Is it is not even? Means it's not equal to 1. Something like that. Okay. This is a too long, lengthier process if you want to check a number, whether it is odd or even. So I'm going to use logical bitwise operation, and ours is bitwise logical operation or instruction, whatever you can say. Let me call it instruction. So I'm going to use AND. So using AND, I'm going to check whether a number is odd or even. You already know odd. The truth table of, you already know AND. The truth table of AND is if both the input is 0, of course the result is 0. Let's assume either of the input. One of the input is 1. Still the output is 0. In case if both the inputs are 1, yeah, you get a 1. Okay, this is the truth table of AND. So using this concept, we are going to check whether a number is odd or even. Very simple. Let's assume you have a number, register T1 is 5. I'm going to check is it odd or even. Okay, so what are you going to do is, let's have another register T2 and keep 1 in that register. Okay, now I'm going to make a bitwise AND operation with 5 and 1. When I do with the 5 and 1 AND operation with the 5 and 1, so what I'm going to do, I'm going to do an AND operation, and let's say T0, the result will be in T0. So my number is T1 with 1. T2 is 1. So I'm going to do the AND operation. When I do the AND operation, I'll get a result. That result is stored here. If this destination register is 1, then means the number is odd. If the destination register, whatever I get the result is in the T0. If the T0 is 1, the number is odd. If the T0 is 0, the number is even. Let's look into the above example. My value is T1, which is 5. 5 means 1, actually we need to write 32 bits. I don't have time, so I'm writing only the necessary bit. So let's assume 5 means 1, 0, 1. Okay. And the another register is T2. What is T2 containing? It contains 1. So it contains 1. The rest of the bits are 0, 0, 0. When I do AND, so AND truth table is here. If both the bits are 1, you get a, if both the bits are 1, you get a 1. So what will be the result of T0? Because this is the one and only bit, it has a similarity. I mean same. The least significant bit is both 1. So you get 1. The rest of the bits are either here 0 or there 0, or here, of course, here all zeros. Here they got 1 and 0 mixed up. So you get a 0. So what is the result you get? You get a 1. So 1 means, if you get a 1, means the given number is odd. In case if you get a 0, then the given number is even.